45 become 27. Okay, so maybe we'll have another 20 minutes. Okay, maybe 20 minutes Anna. Now it's that will finish the class. Okay, so can you see my screen?
Yes, can see.
Okay, thank you. So I did recording. Okay, so just have now we finish chapter 2. Now we are going to the topic number 3 lah. It's an introduction to the electrical machine ha. This one is my research lah. Ni saya terror ni. Yang hit itu saya tak pandai ingat. Nah, tapi boleh lah cari makan boleh lah nah. So yeah, I just want to show you just some idea lah. So before that, you know, any one of you have the experience looking the motor or not? Any one of you? Maybe yes, maybe no lah nah. So let me tell you that I mean just share with you lah. This one is a permanent magnet lah. Permanent magnet lah. This is magnet. Okay, then this is a brush. Commutator, sorry, commutator. If you still remember, commutator. Okay, then the winding. Okay, apa ni yang hijau-hijau? I don't know why is that this one. Maybe it's the stator code. Maybe motor. DC motor. And then yeah, this one also commutator. So you can see sini dia hitam sikit. Actually we will have a carbon brush to push here. Nah, carbon brush. And then this is the rotor, rotating part is rotor. This is stator. Static, no rotation, no? Okay. And then winding. So winding you will coil like this, go inside, then go out. Okay, go inside, go out. Dia punya structure. Then the fan. So this one is air force. Air force. Okay. This one is induction machine. Induction machine. So this is a stator. Usually we first need to see rotor. Okay, shaft. Then bearing. Nameplate. This is radiator. We call sing. 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 Okay, and then winding this is a laminator. I think paper laminator. So we can see this is a square cage. Squirrel cage induction motor. Maybe some of you who did FYP, maybe you need to know a little bit lah. So this is end ring. Then this is the dia dalam dia ada rotobar pergi sini rotobar dia. Okay, you see the line here, actually inside got rotobar. The line here inside got rotobar. Okay, so this is induction machine. So radial flux. Radial flux means the flux is flow through from the center like this. This is called radial flux. Is go out from the center or go into the center. Radially. Axially. Axial means this is the shaft, right? Because this is the shaft. This hitam one is a shaft. Okay, so maybe I show you the shaft dia masuk paper so this one dia keluar daripada dia punya shaft. This is radial flux. For example, this is shaft, right? And then the sparks flow through like this. And then flow like this. Either in, either out lah. Okay. Then you see this one is a shaft. So the shaft is here also. Okay. but the flux is going in the shaft direction. Ni dia tak going through like this. So this is radial. Go to the center point. Okay. This one dia follow shaft direction. We call axial. Right? So axial flux machine. We have a stator. We have a stator. This is dia punya winding lah. Winding. Then we have a rotor. So dia punya the flux will flow go like this and then go back. Go like this then go back. Then radially, this is a shaft, right? This is a shaft. Then when the flux is flow like this, then this is axial. When the flux is flow through outside from the rotor to stator and then go back to the rotor and then again, this is the radial flux. Okay. Do you know where can we see this motor or not? In computer, do you know where can we see this motor or not? Class, do you know or not?
Don't know.
No. Okay. This one CD-ROM. CD-ROM. And also hard disk. Hard disk. Okay. I think this one is CD-ROM lah, CD-ROM. So this is the rotating part. This is the stator part. Or stator. So this is the stator part. And then this one is a Hall effect sensor. Okay. So this is the magnet. Okay. Then gesture, winding. Okay. So this is just for introduction, introduction. And then yeah, so we continue lah, since we are in here already. Okay, so typical structure of a motor drive system, motor and drive, they abang adik now. Yeah, abang adik. It cannot. Motor cannot stand alone without drive. Drive also cannot stand alone without motor. So, you know, this is abang adik, a wife and husband. So, for example, now we have a motor. We have an induction motor. Then we need to drive it by using power electronic converter, like MOSFET, IGBT, FET, SCR. Then we also have a microcontroller, a gate array or IC logic. And then to do what? To use the motor to drive the pump, fan, compressor, machinery, automotive appliances, something like this. Nah? And then this is the full map. Not really very full, it's a partial full. Okay, what we have now, oh, maybe I should open up this one. Okay. Okay, electric motors, we have two types, subdivided into AC to DC. So for AC one, we have a synchronous and synchronous machine. A synchronous is an induction motor. Then induction motor can become a polyphase or single phase. Then from a single phase, either we have a capacitor, run motor, or shaded pole motor. And then polyphase, we can have a wooden or square cage. For example, square cage, this one I show you. This one is square cage. This one is square cage. And then synchronous motor, for the AC one, we can have a brushless, sine wave, hysteresis, step, reluctant. Okay, and then DC, before we go synchronous, DC motor, we have a commutator and homopolar. Commutator is this one. This inside here is commutator. And then majorly is commutator. PM motor is this one. This is the PM motor. Commutator with the PM motor. And then what else we have? Windshield, shunt, compound, series, universal. I think you have undergo this type of a motor during a 3086. Then now in this subject, we are focusing on a synchronous, and then synchronous with a brushless DC motor Then these few types is quite emerging motor. For your information, I think hybrid car is using brushless DC motor. And then I'm not sure whether do you heard about Dyson or not. Dyson is actually using reluctant motor. This one, switch reluctant motor, Dyson, and this is the cheapest motor. The cheapest motor, and yet when we buy the Dyson, it's very expensive, few thousand, you know. This is the street reluctant motor, it's the cheapest one, the lowest efficiency motor. And then okay, this is a cross section of the motor lah. It's quite difficult to see from the cross sectional. Maybe you can have a look on the so-called the hardware and then come back to here. Nah? For example, AC induction motor. I'm not sure whether can you see or not, but when we chop this one, okay, we chop in this here, then we will have the stator. Then we chop here, then we will see the center. Same as well, the other thing. This is a street reluctant motor where Dyson use. And then we will focus here. This is our topic. For example, DC preamp brush motor. This commutator, right? Commutator is this one. This is commutator. And then inside armature dia punya rotor part. This is rotor part. And then we have a permanent magnet and stator part. Permanent magnet and stator part. This is the magnet and stator part outside here. So when we chop half, then we will see this. Chop inside lah, cross section there. So first generation motor of the classical motor, we have a DC motor, AC synchronous, and AC induction. The term classical emphasizes the fact that these motors satisfy three important criteria. They all produce essential constant instantaneous torque, very little torque ripple. And then they operate from a pure DC or AC supply, which means ada ni. Classical punya just directly inject then drive. This is classical. Then they can run without electronic controller. For example, we call line start lah. Okay, so I think we stop here. Okay, before do you want me to continue? Guys,
stop right there.
Stop here, Lana. We stop
Yes,
here, then we continue on the replacement class. Let me stop the stop sharing first, and also stop recording first before we